Okay, so in this class we will discuss the first problem. Evaluate integral 0 to infinity lambda square d lambda by a square plus lambda square into b square plus lambda square. Okay, so in this class we will discuss the problem. So in this class we will discuss the problem. So evaluate lambda square d lambda divided by a square plus lambda square into b square plus lambda square. So actually in this problem you have uh, actually in the previous class we discussed a problem. The numerator is a constant 1. Okay, so in this problem you have the numerator, you have lambda square, or sometimes you have instead of lambda square they will give x square. So x square here also a square plus x square plus b square plus x square, like this. So if in the numerator you have 1, then we should apply Fourier cosine transform for f of x and g of x. The same f of x, the same g of x. If you have the numerator is x square or lambda square, then you should apply Fourier sine transform. So let us take f of x equal to e power minus ax and g of x equal to e power minus bx. So we know that Fourier sine transform of e power minus ax is, that is we derived in the previous class, root 2 by pi s by s square plus a square. So I will take that is a function of s. And similarly, g of x is equal to e power minus b e power minus bx. Fourier sine transform of e power minus bx is root 2 by pi a by s square plus b square. So this is what gs of s. So I think that in the previous class I gave 3 identities. So now I am going to use one of the identity. So here I have fs of s and gs of s. So that's the reason I am going to use what? Integral 0 to infinity fs of s gs of s is equal to ds is equal to 0 to infinity 0 to infinity f of x into g of x into dx. So now if I multiply fs of s and gs of s, you'll get 2 by pi s square by s square by s square plus a square into s square plus b square into ds equal to 0 to infinity f of x is e power minus ax, g of x is what? E power minus bx dx. Now integrate the right hand side. So 0 to infinity, you have what? E power minus of a plus b into x dx. So if you integrate e power minus a plus b x, you'll get what? E power minus of a plus b into x by minus of a plus b. The limit is from 0 to infinity. So minus 1 by a plus 1 take common. So if you substitute the upper limit, you will get e power minus infinity 0. Lower limit is what? 1. So the right hand side is 1 by a plus b. The left hand side, the same function you can see here. The 2 by pi integral 0 to infinity, okay, integral 0 to infinity, s square by s square plus a square into s square plus b square into ds. The same functions you have. Now I have this, I need only this integral, cross multiply 2 by pi. So you will get integral 0 to infinity a square ds by a square plus a square into a square plus b square is pi by 2 into a plus b. So I need the final answer in terms of lambda. So suppose the final answer is in terms of x, means replace the dummy variable from s to x. Here I need the answer in terms of lambda. That's why I replace the dummy variable from s to lambda. You will get what? Lambda square into d lambda by lambda square plus a square into lambda square plus b square is equal to pi by 2 into a plus b. So this is the first problem. And then second problem, find the Fourier cosine transform of f of x is equal to cos
So
x.
you didn't share the
Sorry.
screen.
Sorry.
Just share the screen.
Yes. At least you showed now. You told to me now. Otherwise, thank you, Gidika. Okay.
Okay, sir.
Okay. Okay. So actually, yeah. So this is the problem. I told last 3 minutes I explained. Okay. So just now, okay. So evaluate integral 0 to infinity lambda square d lambda by a square plus lambda square into b square plus lambda square. So this is the problem. So here, in the numerator we have what? Lambda square. So in the previous class we solved the problem. I think in the lambda, instead of lambda square you have 1. Okay. So in that problem we calculated what? We found Fourier cosine transform. If you have a variable like this lambda square or x square, you should apply what? Fourier sine transform. So you here have a and b, or a square and b square. That's why take f of x equal to what? E power ax, and g of x is what? E power minus bx. So Fourier sine transform of e power minus ax is, we know that root 2 by pi s by s square plus a square. So that is equal to fs of s. Similarly, Fourier sine transform of e power minus bx is root 2 by pi s by s square plus b square is equal to gs of s. Now, I'm going to use the identity. So in the previous class, I gave 3 identities. So this is one of the identity. Integral 0 to infinity fs of s into gs of s is equal dx is equal to 0 to infinity f of x dx f of x into g of x into dx. Okay, now so f of s into g of s. If you multiply these two, you'll get what? 2 by pi x square by s square plus a square into what? S square plus b square into ds is equal to 0 to infinity. F of x is what? F of x is e power minus ax, g of x is e power minus bx into dx. Now integrate the right hand side. So the right hand side is 0 to infinity. You can write what? E power minus of a plus b into x into dx. So if you integrate this function, you'll get what? E power minus of a plus b into x by minus of a plus b. The limit is from 0 to infinity, okay, which is equal to minus of 1 by a plus b. Okay, if you substitute the upper limit, you'll get e power minus infinity is what? 0 minus e power 0 is what? 1. So the right hand side is 1 by a plus b. The left hand side is as it is in the previous step. You can see here the same thing. So now I need only this integral. So integral 0 to infinity s square into ds by s square plus a square into s square plus b square is pi by 2 into a plus b. So now I need the answer in terms of lambda. So that's why I change the dummy variable from s to lambda. So we will get the final answer. The second problem, find the Fourier cosine transform of f of x is equal to cos x. X lies between 0 and a, and 0 when x is greater than or equal to a. The first step, write the definition of Fourier cosine transform of f of x. So that is asked in the question. So root 2 by pi 0 to infinity f of x into cos sx dx. We know that from 0 to a f of x is cos x. The remaining interval what? It is 0. So that's why you can split the integral 0 to a and then a to infinity. So 0 to a f of x is cos x, a to infinity 0. So the second integral is 0. Now I am going to write, I'll take cos sx into cos x. I'll take this is a, sx is a, b is x. So now this is 2 cos A cos B formula. So 2 is not here, that's why I'll divide by 2. So is what? 2 cos A cos B is cos of A plus B plus cos of A minus B divided by 2. So s plus 1 into x plus what? Similarly, A minus B is what? S minus 1 into x. Next step, integration. Next step is integration. Okay. The next step is integration. If you integrate, it's actually what? Here we have 2. So if we simplify this, you'll get what? 1 by root 2 pi. If you integrate cos s plus 1x, you'll get what? Sin s plus 1x by s plus 1 plus sin s minus 1 x by s minus 1. The limit is from 0 to a. So if you substitute the upper limit, 1 by root 2 pi sin s plus 1 into a by s plus 1 plus sin s minus 1 into a by s minus 1. Lower limit is what? Sin 0 0 sin 0 0. So you'll get this answer. So this is valid if what? S is not equal to 1 and s is not equal to minus 1. Okay. Now I'll go move to the third problem now. Find the Fourier sine transform of Fourier sine transform of 1 by x. Okay. So now solution fs of 1 by x, so which is equal to root 2 by pi integral 0 to infinity f of x is 1 by x into sine sx into dx. Okay, so now you can take this sx is equal to some theta or t. Sx is equal to okay theta. So now this interval is reduces to 0 to 2 by pi integral 0 to infinity. So the numerator is what? Sine theta by x is what? Theta by s. Theta by s into dx is what? Dx is d theta by s. So s gets cancelled. You have this is what? Root 2 by pi integration 0 to infinity sine theta by theta into d theta. So the value of the integral 0 to infinity sine theta by d theta, sine theta by theta and d theta is pi by 2. So directly you can use that result root 2 by pi into pi by 2. So the final answer is root pi by 2. So this is the final answer. Root pi by 2. Okay. So now, okay, we'll move to the fourth problem. Find Fourier sine and cosine transform of x power n minus 1. find Fourier sine and cosine transform of x power n minus 1. Okay, so I'll write the solution. So actually here we need to use gamma function this problem. Okay, first I will write gamma of n equal to integral 0 to infinity. So usually we'll write e power minus x. Okay, okay, I will write e power minus y power n minus 1 into dy. So this is the gamma function definition. Now I'm going to substitute y is equal to ax. So then we will get gamma of n equal to integral x is equal to 0 to infinity e power minus e power minus ax. Y is what? Ax whole power n minus 1 into dy is what? A into dx. So now gamma of n equal to integral. So a power what? A power uh, n minus 1 here, 1. So a power n. I'll take it out. A power n integral 0 to infinity e power minus ax into x power what? N minus 1 into dx. Okay, now I am going to write the value of this integral is equal to integral 0 to infinity e power minus ax into x power n minus 1 dx is equal to gamma of n by a power n. I will write in the next step. Integral 0 to infinity e power minus ax okay, e power minus ax into x power n minus 1 into dx is equal to gamma of n by a power n. Gamma of n by a power n. Okay, now again I am going to substitute here. Put a is equal to is because I need a cos and sine. So that's why I am going to put a is equal to is. So integral 0 to infinity e power what? Minus isx into x power n minus 1 into dx, which is equal to gamma of n by a equal to what? Is whole power n. So which is equal to the next step, integral 0 to infinity e power minus isx is what? Cos sx minus I sin sx into x power n minus 1 into dx, which is equal to, you can write 1 by I is what? Minus I whole power n gamma of n by s power n. Okay, so now you can write this is the right hand side is gamma of n by s power n. You can write minus I is 1 by I is minus n, and you can write this is what? Minus n. The power is what? Minus n. Okay? Because here the denominator will have what? I power n. 1 by I is minus I, and if I write in the numerator, this is what? Minus n. So now minus I, you can write what? Cos pi by 2. Uh, I think 1 by n, I think I'm doing some mistake. 1 by I is minus I. So I power n. Uh, I think here we have plus only. So I'll write, okay. So I will write actually what? 1 by I power n. If I write in the numerator, this is what? I power minus n. So here what? I is what? You can write I is cos pi by 2 plus what? I sin pi by 2, sin pi by 2. Okay. Mm, whole whole power what? Whole power minus n into gamma of n by s power n is here. Okay. Now, which is equal to, by using de Moivre's theorem, gamma of n by s power n. What is this? Cos of minus n pi by 2 is cos n pi by 2, and then minus, because sine of what? Minus n pi by 2 is minus I into sine n pi by 2. So close the bracket. So now equating the real and imaginary part. Next step, I am going to equate the real and imaginary part. First, I equate the real part. Equating the real part. So on the left hand side, what is the real part? 0 to infinity cos sx into what? X power n minus 1 dx. 0 to infinity. First, I will write x power n minus 1 into cos sx into dx. So which is equal to the right hand side, what is the real part? Gamma of n by s power n into what? Cos n pi by 2. Gamma of n by s power n into cos n pi by 2. Okay. Maybe I will call equation number 1, or okay. So now actually here what is missing? Actually the root 2 by pi is missing on both sides. So multiply both sides by root 2 by pi. So you'll get integral 0 to infinity x power n minus 1 into cos sx dx. So then only you can write this is what? Fourier cosine transform of x power n minus 1. That's why I'm going to multiply root 2 by pi. So if I multiply the left hand side, should multiply the right hand side also. Root 2 by pi gamma of n by s power n cos n pi by 2. So this is actually what? Fourier cosine transform of x power n minus 1, which is equal to root 2 by pi gamma of n by s power n into cos n pi by 2. Okay. The question is actually find the Fourier cosine and the Fourier sine transform. I will call this is equation number 1. Now equate the imaginary part. Equating imaginary part. The left hand side you have I think minus integral 0 to infinity x power n minus 1 into sine sx dx. So here also you'll get minus. Here also you'll have what? Minus gamma of n by s power n into what? Sine n pi by 2. So minus minus gets cancelled. Directly I will write integral 0 to infinity x power n minus 1 into sine sx into dx, which is equal to gamma of n by s power n, gamma of n s power n into what? Sine n pi by 2. Now again here I'm going to multiply both sides by what? Root 2 by pi. Root 2 by pi integral 0 to infinity x power n minus 1 sine sx into dx, which is equal to root 2 by pi. Okay, sine gamma of n by s power n, gamma of n by s power n. Actually, this is gamma of n. The numerator is what? Gamma of n into what? Sine n pi by 2. So the left hand side is, by definition, this is what? Fourier sine transform of x power n minus 1. X power n minus 1, which is equal to root 2 by pi into gamma of n by s power n into sine n pi by 2. So, okay, I'll call this is equation number 2. Okay. Actually, there is one more deduction part in the question. Actually, I forgot to give the deduction part. So also we need to prove that 1 by root x is self-reciprocal under Fourier sine into Fourier cosine transform. I will add, if possible, I will add here. Also prove that 1 by root x is self-reciprocal under Fourier sine and Fourier cosine transform. Fourier sine and Fourier cosine transform. Fourier sine and Fourier cosine transforms. Okay. So now, so in the equation 1, I am going to substitute n equal to 1 by 2, both left hand side and right hand side. So in equation 1, put n equal to 1 by 2. So then we'll get fc of what? X power minus half or you can write 1 by what? Root x, which is equal to root 2 by pi, root 2 by pi into gamma of half, n equal to half. Gamma of half is root pi, gamma of half is root pi by you have what? S power what? N, that is s power half is what? Root s, and then n equal to half. N equal to half na cos pi by 4. Cos pi by 4 is 1 by root 2. So which is equal to root gets cancelled. Root pi gets cancelled. We'll get what? Root 1 by root s. So this implies 1 by root s. Root x is self-reciprocal. Under Fourier cosine transform. Fourier cosine transform. Similarly, substitute n equal to 1 by 2 in equation 2. Actually in 1 here, okay, in 1. So next in 2, put n equal to 1 by 2. Similarly, you will get what? Fs of 1 by root x is equal to root 2 by pi. Root 2 by pi. Gamma of half is what? Root pi. Root 2 by pi. Gamma of half is root pi divided by s power n. It is s power half is what? Root s into sine pi by 4. Sine pi by 4 is 1 by root 2. So again you'll get root 2 gets cancelled. Root pi gets cancelled. 1 by root s. So fs of 1 by root x is equal to 1 by root s. This implies 1 by root x is self reciprocal under Fourier sine transform. Fourier sine transform. Okay. So next problem, maybe I think a fifth problem. Show that subdivision number 1, fs of Fourier sine transform of x into f of x is equal to minus d by ds of fc of s you can write, okay, or minus d by ds of fs of f of x also you can write. Fs of f of x, or this is equal to okay, this is equal to minus d by ds of fs of f of x is fs of s. Sorry, here I done the mistake. It's not fs, this is fc. fc of f of x. fc of f of x. Here also what? fc of s. So fs of x into f of x is equal to, so instead of this x, okay, you have what? Minus d by dx into fc. Here fs means here what? fc of this f of x. So replace x by what? Minus d by ds, and then instead of fs, you should calculate what? Fc of f of x. Or you can write this is equal to what? Minus d by ds. Fc of f of x is what? Fc of s. Similarly, subdivision number 2, Fc of x into f of x, which is equal to, similarly here what? Minus, not minus, plus d by ds. Here Fc na, here fs of f of x, close the bracket, which is equal to d by ds of fs of f of x is fs of s. So we should prove these two. Okay, and hence there is one more result, and hence find Fourier sine and cosine transform of Fourier sine and cosine transform of sine transform of x into e power minus ax. Okay, so we will do one by one. Solution. So first I'll calculate Fc of f of x. By definition, Fc of f of x is root 2 by pi, or you can start from Fc of s. Okay, Fc of s is equal to Fc of s is equal to Fc of f of x is equal to which is equal to root 2 by pi integral 0 to infinity f of x into cos sx, f of x into cos sx into dx. Now I am going to see here Fc of s, Fc of s. So now I am going to differentiate d by ds of what? Fc of s. I am going to find d by ds of Fc of s, which is equal to root 2 by pi. So integral 0 to infinity. I am going to differentiate here with respect to what? S. So keep x is constant. So if you differentiate cos sx with respect to s, you'll get what? Minus sine sx into x into dx. So which is equal to minus root 2 by pi 0 to infinity x into f of x into sine sx into sine sx into dx. So now, so this is equal to, I will write this is the left hand side. Okay, or you can write no problem. So which is equal to minus, this is what? F s Fourier sine transform of what? X into f of x. So or you can write fs of x into f of x is equal to minus d by ds of minus d by ds of fc of s. Or you can stop here, or you can write this is what? Minus d by ds of fc of s is what? Fourier cosine transform of f of x. So this is the first result we proved. You can check fs of x into fs of x into f of x is equal to what? Minus d by ds of what? fc of s, or minus d by ds of fc of f of x. So for the second result, I am going to consider fs of f of x or fs of s. So I'll start from fs of s. Okay, subdivision 1. This is subdivision 1. Subdivision 2 next. So fs of s, which is equal to fs of f of x, which is equal to root 2 by pi integral 0 to infinity f of x into sine sx into dx. Now, as usual, we should differentiate as in the previous subdivision d by ds of fs of s, which is equal to root 2 by pi integral 0 to infinity f of x into, we differentiate sin sx, we'll get what? Cos sx into with respect to SR, so we'll get x into dx. To differentiate sx, we'll get x. So this is equal to root 2 by pi limit 0 to infinity x into f of x into f of x um, into cos sx dx. So this is equal to root 2 by pi. The right hand side is what? Fourier cosine transform of x into f of x. Okay, so now, sorry. So I don't, okay, actually, including this only, I have what? Fourier cosine transform of x into f of x. Okay, now, Fourier, okay, or otherwise, what we need? Please check the fc of x into f of x, fc of x into f of x, which is equal to d by ds of what? Fs of s which is equal to d by ds of fs of s is nothing but fs of f of x. So actually the problem, to solve the problems, you will use this relation only. Okay, this is useful. Similarly, to solve the problem, this relation is what? Useful. Okay. So and hence you need to find what? Fourier sine and Fourier cosine transform of what? X into e power minus ax. So now first I am going to find Fourier sine transform of x into e power minus ax. Fourier sine transform of x into e power minus ax. So for this I am going to use the result fs of x into f of x. So fs of x into f of x is what? Fs of x into f of x is minus d by ds of fc of f of x minus d by ds of fc of f of x. F of x is what? E power minus ax. So already we know the Fourier cosine transform of fc of e power minus ax. That is what? Root 2 by pi a by s square plus a square. So now if you differentiate this function with respect to s, you will get here have minus root 2 by pi. So 1 by x, differentiate 1 by x will get what? Minus 1 by minus here have a s square plus a square whole square, and if you differentiate s square plus a square, you get what? 2s. So the final answer for Fourier sine transform of x into e power minus ax is equal to root 2 by pi minus of minus plus root 2 by pi 2as by x square plus a square whole square. So this is the Fourier sine transform of x into e power minus x. Similarly, Fourier cosine transform of x into e power minus ax. So again, I'm going to use the result fc. Fc of x into f of x is what? D by ds of fs of f of x. D by ds of fs of f of x is here what? E power minus ax. Okay, so which is equal to d by ds of what is fs of e power minus ax? Root 2 by pi. Root 2 by pi into s by what? Into s by s square plus a square. Okay. Now root 2 by pi is constant. So u by v method. If you differentiate s square plus a square whole square, so keep a square plus a square in the numerator. If you differentiate s, you'll get what? 1 minus, okay, s into, if you differentiate the denominator, you'll get 2s. So the final answer, which is equal to root 2 by pi into a square minus s square by s square plus a square whole square. So this is the final answer. We will solve one more problem, and sixth problem. Find the Fourier cosine transform of, okay, find the Fourier cosine transform of e power minus a square into x square, e power minus a square x square, and hence evaluate, of Fourier sine transform of Fourier sine transform of x into e power minus a square x square. Also show that show that e power minus x square by 2, e power minus x square by 2 is self reciprocal under Fourier cosine transform. Under Fourier cosine transform. Okay. So we will do one by one, but it will not take maximum 10 minutes. We can finish it quickly. So start from Fourier cosine transform of e power minus a square x square. So which is equal to, by definition, what is this? This is equal to root 2 by pi root 2 by pi integral 0 to infinity 0 to infinity e power what? Minus a square x square into cos sx into dx. Okay, so now here I'm going to do, actually this is an even function. E power minus a square x square is an even function. Cos sx is even. So even into even, even. So totally this is an even function. So you can write okay, you can write, because yes, the integrand is what? Even function totally. So that's why you can write this is 2 by pi. So you can write 1 by 2 times, the limit is from minus infinity plus infinity, e power minus a square x square. So this is a crucial step, into cos sx into dx. So because of, suppose if you have minus infinity plus infinity even function, then you can write what? 2 times 0 to infinity and the integrand. Here I am converting from 0 to infinity to minus infinity plus infinity. So that's why here you have what? 1 by 2, and this is an even function. So we are doing a little bit reverse side. Okay. Usually we will not do like this. We will convert, usually we will convert from minus infinity plus infinity, 0 to infinity. But this time we are converting from where? 0 to infinity to minus infinity plus infinity. Okay, now this is equal to 1 by root 2 pi, 1 by root 2 pi, minus infinity to plus infinity, e power minus a square into x square. I will write this is a real part of e power isx into dx. So this is cos sx plus I sin x. Real part is what? Cos sx. The next step, I will take real part outside the integral, which is equal to real part of 1 by root 2 pi integral 0 to infinity. So I think what is common here? I'll take e power minus a square x square. Here what? E power isx. So I'll take minus common. Okay, first write e power minus a square x square into e power isx dx. In the next step, I'm going to write real part of 1 by root 2 pi integral 0 to infinity e power, take minus common, you have what? A square x square minus isx into dx. I think there is no need to write this one. Okay, this step. Actually, this is nothing but the previous step. Okay, wow. The previous step is nothing but Fourier transform of, I think what the limit is what here? I think minus infinity plus infinity. Okay, I done the mistake here. The limit is from minus infinity to plus infinity. So now 1 by root 2 pi minus infinity plus infinity e power minus a square x square into e power isx dx is what? Fourier transform of the function f of x. What is f of x? E power minus a square into x square. So actually we derived this result already in the classroom, the online class. So Fourier transform of e power minus a square x square is mm, okay. So please verify. I think we'll get 1 by a root 2 into e power minus s square by 4a square. But in the examination, you need to do again from here to here. So I will check the result also once again. Uh, I think I got the same answer. Fourier transform of e power minus a square x square. Fourier transform. Yes, 1 by a root 2 into e power minus s square by 4a square. Yes, okay. Now, the first part is nearly over. Actually, what is the left hand side? The left hand side is Fourier cosine transform of what? Fourier cosine transform of e power minus a square x square, which is equal to, so actually this is the real part. There is no need to write again a real part. 1 by a into root 2 into e power minus x square by 4a square. The first part is over. So find the Fourier cosine transform of e power minus a square x square. Next, I need to evaluate Fourier sine transform of x into e power minus a square into x square. Fourier, I'll write in the Fourier sine transform of x into e power minus a square into x square, which is equal to, so I think already we discussed the result, fs of x into f of x. Fs of x into f of x is what? Minus d by ds of fc of f of x. Minus d by ds of minus d by ds of fc of f of x. So what is f of x is what? Here e power minus a square x square. So which is equal to minus d by ds what is fc of e power minus a square x square? 1 by a root 2 so into e power e power minus s square by 4a square. E power minus s square by 4a square. I can't write here. Okay, I'll write. So which is equal to minus d by ds of fc of e power minus a square x square. Sorry. So that is I am writing again. So fc of 1 by a root 2 into e power minus s square by 4a square. Okay, now if you differentiate, you get minus 1 by a root 2. So if you differentiate e power x, you'll get what? E power minus s square by 4a square into minus 2s by 4a square. So if you simplify, you will get minus of minus plus. Okay, 1 by, you'll get what? 4 into 2 root 2. Okay, right. 2 root 2, 1 by 2 root 2 into a cube into, here I can write s, this s I will write here, s into e power what? Minus s square by 4a square. So this is actually what? Fourier sine transform of x into e power minus a square into x square. So second part is also over. Last one. Okay, last one is what? Also show that e power minus x square by 2 is what? Self-reciprocal under Fourier cosine transform. Okay, so here I'll take, this is equation number 1. So in equation 1, substitute a equal to 1 by root 2 in equation 1. Put a equal to 1 by root 2. So then what you'll get? So fc of e power minus x square by 2. So I'll write, we'll get, I'll write here. Okay, I'll write in the next slide. fc of, I'm going to substitute what? X, a equal to 1 by root 2. A equal to 1 by root 2 na e power minus x square by 2. Okay, in the right hand side you have what? You have 1 by, a is what? 1 by root 2, 1 by root 2. So they'll get cancelled. Get 1 by root 2 into 1 by root 2. A equal to 1 by root 2 into root 2. And then you have e power minus s square by 4a square. E power minus s square by 4a square. A square is what? 1 by 2. So you will get root to root gets cancelled. You get what? E power minus s square by 2. The left hand side is what? fc of e power minus x square by 2. So this implies e power minus x square by 2 is self-reciprocal under Fourier cosine transform. Under Fourier cosine transform. Okay, I will stop here. So if you have any doubts, you can ask to me. Otherwise, we will meet tomorrow. Okay. Okay. Thank you, everyone.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you.